welcome to 6.5. I'm going to be going over your answers for 6.4 here quick for you guys to check over. And then I'm going to teach you guys about side similarity and side angle side similarity, similarly to angle similarity. There's my pun of the video. I should start doing that, pun of the video. Really bad math puns. Here is the second page of your answers. Okay, so as I mentioned here, we're going to work with side similarity and side angle side similarity. The first one allows you to see if two triangles are similar without having any of their angle measurements. So you see if their corresponding side lengths are proportional. If they are, then the two triangles are similar. So I'm going to do an example or two for that. It says which one of these two triangles, or maybe they both might be, are similar to triangle ABC. So I'm going to compare their side lengths. Let's do 8 over 6 equals 12 over 9 equals 16 over 12. And that reduces to 4/3, 4/3, and 4/3. So this one works out great. Let's just double check the other one. I have 16 over 16. I have 8 over 8. And I have, well, 12 over 10. That definitely does not work. 1 equals 1 does not equal 1.2. So that one's going to be no. And then here, what they want you to do is find the value of x that makes them similar. So we're going to use the side similarity. We're going to compare 4 over 12. So I'm comparing this to this, and then we'll compare this to this. So x minus 1 over 18. What I'm going to do here is the 4 over 12 reduces to 1 over 3. So I'm going to make the problem a little bit easier to work with by reducing my fraction on the left-hand side. This is something that you can do. So 1 times 18 is 18. 3 times x minus 1 is 3x minus 3. If you add the 3, it gives you 21. Divide by 3 to get 7 for our x. And let's go ahead and plug that in just to make sure that we've done this right. So 7 minus 1 is 6. And then 7 plus 1 is 8. 8 times 3 is 24. So I have 4 over 12 equals 6 over 18 equals 8 over 24. And all of these reduce to 1/3. And so it does work out perfectly. Okay, and then we're going to skip over that. We're going to get into side angle side similarity. So this is if you have a congruent angle, and then the side lengths that make up those angles are proportional. Then the two triangles are going to be similar by what we call side angle side similarity. So we have started with angle. This was 6.4, and now we have 6.5 and 6.5. We have two new ones. So those are the three ways, the three shortcuts for showing two triangles are similar. And that's basically all there is to it. These are kind of fun problems. We're going to talk about this later on in the year, but it's kind of cool to explore it on your own. And then 33 and 34 are kind of fun as well. So give those a try. Let me know if you have any questions, and I'll see you in class. Before I go, I just want to make sure that I kind of talk about this, because these problems come up in the book a lot. When you have overlapping triangles and you're trying to show that they're similar, let's say they have like this is 4 and this is 3 and this is, I don't know, 5 and this is, I don't know, 2, whatever. I'm just making up some numbers here. You have this angle that's reflective right here, but you got to check the side lengths, and so to see if they're proportional. So what you want to do is you want to pull apart the triangles 4 and 5, and then this whole side length is 7, is 4 plus 3, and this whole side length is 7 here. So you'd have 4 over 7 equals 5 over 7, and this would be no. So these two triangles, sorry about the bell ringing, those two triangles would not be similar, but you can use this strategy, and so just make sure you're using the full side lengths here. This is a common mistake that students make, is they do 4 over 3 and 5 over 2. All right, now I'm done. Thank you.